This video is going to go through an example of finding the magnitude and direction of a resultant force given two forces acting at a point. Given the picture shown, we need to find the magnitude and direction of the resultant force. We see that F1 is acting due east or strictly in the positive x direction at 875 newtons, while F2 is acting due north or strictly in the positive y direction at 325 newtons. We want to find the resultant force, which is going to act somewhere in between F1 and F2. First, just like when we had wind vectors, we need to separate the forces into their x components and their y components. The x component of F1 is 875 newtons, while its y component is 0, since the force is acting only in the x direction. The x component of F2 is 0, since it is only acting in the y direction, so its y component is 325 newtons. Both the y component of F2 and the x component of F1 are positive, since these forces are acting to the right and up respectively. Don't forget to check to make sure you are using the correct sign for each of your component vectors. Next, since we are trying to find the resultant force, we need to use vector addition to add the forces acting in x and the forces acting in y separately. When we add the x components, 875 newtons plus 0 newtons, we see that the resultant x component is 875 newtons. When we add the y components, 0 newtons plus 325 newtons, we see the resultant y component is 325 newtons. Now, to find the magnitude of the resultant force, we are going to use Pythagoras Theorem. Since we have the x component and the y component forces, we can take the magnitude of the resultant x component squared and add the magnitude of the resultant y component squared. Then we take the square root, and this will give us the magnitude of the resultant force. Substituting in our values, we have 875 newtons squared plus 325 newtons squared. Taking the square root, we see the resultant force has a magnitude of 934 newtons. Last, we need to find the angle at which this force is acting. To find the missing angle, we will use trigonometry. Tangent of the angle, alpha, is equal to the magnitude of the resultant y component divided by the magnitude of the resultant x component. This means tangent of the angle is equal to 325 newtons divided by 875 newtons. This gives us an angle of 20.4 degrees. Therefore, our resultant force has a magnitude of 934 newtons at 20.4 degrees. This concludes our example of finding the resultant force.